now we will look at molecular and empirical formula. Molecular formulae is the actual number of atoms of the different elements in a compound, while the empirical formulae is the simplest whole number ratio of atoms of the different elements in the compound. So if we were to take this example, which is called ethene, it has the molecular formula C2H4. But if I were to simplify it to the simplest whole number ratio, 2 is to 4 can actually be simplified to 1 is to 2. So the empirical formula of this molecule will actually be CH2. This is a typical question that we come across involving empirical and molecular formulae. So we have an unknown compound X that is made up of carbon, hydrogen, and oxygen. And it undergoes complete combustion to give carbon dioxide and water. Complete combustion means that it burns completely in oxygen and all the carbon forms carbon dioxide and not carbon monoxide. Because I don't know the molecular formula of this compound, let's just let it be CX, HY, and OZ. Please note that all the carbon in carbon dioxide comes from the compound. All the hydrogen in water comes from the compound as well. So based on the mass of the carbon dioxide here and the mass of water, I should be able to find the mass of carbon and the mass of hydrogen in 0.5 grams of this compound. So how do we find the mass of carbon? We will start by taking the mass of carbon dioxide here, 0.6875, and we divide it by the molecular mass or the molar mass of carbon dioxide, which is 12 plus 16 times 2. So this will give us the number of moles of carbon dioxide. Because one molecule of carbon dioxide contains one carbon atom, the number of moles of carbon dioxide and the number of moles of carbon are equal. So I can just take this as the number of moles of carbon and multiply it by the atomic mass of carbon, which is 12, to find the mass of carbon. And this is equal to 0.1875. Then I can do the exact same thing to find the mass of hydrogen. So the mass of hydrogen is equal to 0.5625 divided by the relative molecular mass of water, which is 1 times 2 plus 16. And because one molecule of water has 2 atoms of hydrogen, I need to take the number of moles of water and multiply it by 2 to find the number of moles of hydrogen. And I'll multiply this by the relative atomic mass of hydrogen, which is 1. And this is actually equal to 0.0625. Now, I have the mass of carbon, I have the mass of hydrogen in this 0.5 gram sample of compound X. So what's actually left in the compound is oxygen. So to find the mass of oxygen, it is actually 0.500 minus the carbon, 0.1875, and minus the hydrogen, which is 0.0625. And this is actually 0.250. So now I have found the mass of carbon, the mass of hydrogen, and the mass of oxygen. So let's rewrite this. We know that the mass in grams of carbon, hydrogen, and oxygen are 0.1875, 0.0625, and 0.250 respectively in 0.5 grams of X. So the next step is actually to find the number of moles, which is the amount in moles. So how do you find the number of moles from the mass? You would take the mass and you divide it by the molar mass or the relative molecular mass. So if I take 0.1875, I divide it by 12, you actually get 0.0156. If I take 0.0625 and I divide by 1, you will get the same thing, which is 0.0625. And finally, you take 0.250 and divide it by 16, and this is equal to 0.0156. So now you actually have the ratio of the number of moles. We just need to simplify it to the simplest whole number ratio. And we do that by dividing all three numbers by the smallest amount. So in this case, the smallest amount will be 0.0156. So to find the mole ratio, 0.0156 divided by itself is 1. 0.0625 divided by 0.0156 is actually 4. And 0.0156 divided by itself once again is 1. Therefore, the empirical formula, which is the atoms in the simplest whole number ratio, is CH4O. Alright, so now we've gotten the empirical formula, which is CH4O, and we want to find the actual molecular formula. So we're given that the relative molecular mass of X is 64. So to start off, we let the molecular formula of X be CH4O times N. So what we're trying to find is this unknown N. So the MR of CH4O N is 64. So that means that CH4O, the total molecular mass of this empirical formula, times N should be 64. So what we need to do is we'll take 12 plus 4 times 1, which is 4 times the atomic mass of H, plus 16 times N is equals to 64. And the sum of what's in the brackets here is actually equal to 32.0. N equals to 64.0. Therefore, it's very clear here, N is equal to 2. So the molecular formula would be this multiplied by 2, which will be C2H8O2. Alright, now let's look at a different question. We have a hydrated salt of sodium carbonate, Na2CO3, and when it's heated strongly, we're left with 2.12 grams. So what this strong heating does, it actually eliminates this water of hydration here, which means that the difference between 2.48 and 2.12 is actually this water that was lost. So in order to find this N, there are a few steps that we have to go through. First, let's find how much water there was. So the mass of water is actually simply 2.48 minus 2.12, and that is equal to 0.36 grams. So now let's find the number of moles of water in 0.36 grams, and that is the number of moles of water equals to, if you recall, the mass divided by the molar mass of water or the relative molecular mass of water, and that is 1.0 times 2 plus 16.0, which is equal to 0.02 moles. So now we found the number of moles of water, but that's not enough to determine N. We need to find the ratio of the number of moles of sodium carbonate to the number of moles of water. To do this, we will use this mass of anhydrous salt. Anhydrous salt means there's no water left anymore. So we will take the number of moles of sodium carbonate is equal to 2.12 divided by the relative molecular mass of sodium carbonate. So that will be 23.0 times 2 plus 12.0 plus 16.0 times 3. That is equal to 0.02 moles. So now we see the ratio of water to sodium carbonate is actually 1:1. So N is equal to 1. Alright, now let's look at our last question. We're looking at a mixture of hydrated copper sulfate and hydrated magnesium sulfate, and we are heating this until we are left only with the anhydrous salt of both compounds. So originally we had 5 grams of the mixture, and then we end up with 3 grams of anhydrous salts, and we want to find out how much copper sulfate there was in the original mixture. So to do this, we need to start off by defining our variables x and y. Let the number of moles of the hydrated copper sulfate be x moles, and we'll define the number of moles of hydrated magnesium sulfate as well, which would be y moles. So take note that after this heating, the number of moles of copper sulfate and magnesium sulfate will stay the same. So I can just use the same x and y again. And then if you were to calculate the molar mass or MR of the hydrated copper sulfate, 5H2O, this is equal to 249.6, and the MR of the copper sulfate without the water of hydration is actually 159.6. Now let's do the same for the hydrated magnesium sulfate. Because I am short of space, I'll just write it like this. So the hydrated magnesium sulfate actually has a MR of 246.4, and for the anhydrous magnesium sulfate, it's actually 120.4. So I've defined all my terms and I found all the numbers that I need to. The next thing to do is just to come up with 2 simultaneous equations. So we need to find the mass of copper sulfate and magnesium sulfate in this 5 grams. And that is simply the MR multiplied by the number of moles. So 249.6x plus 246.4y is equal to 5 grams. And 159, this is after the heating, x plus 120.4y is equal to 3 grams. So you can simply use your GC to solve these 2 equations. You'll find that x, that's the only one you are interested in, is actually equal to 0.014794. I'm using 5 significant figures. So I have the number of moles. Now I just need to find the mass. And the mass will actually just be the number of moles, mass, which is this number here, multiplied by the MR 249.6, and you find that that is actually equal to 3.6925 grams. So what's the percentage by mass? It's simply 3.6925 divided by 5 times 100, and you'll find the answer is actually 73.9%.